there must be a left-hand side, there must be a right-hand side. In this case, x equals to 1.5. Moving on to question 6. Now again, we have two graphs that are drawn on the grid. This time, you didn't have to plot anything. But as always, whenever you see two or more graphs on the same axis, pay very close attention to the points of intersection. It's x coordinates and the y coordinates. So we've got two graphs over here. They are not labeled, but surely you know which graph is for which equation. The curve must have the equation, the quadratic equation. In this case, y equals to 2x squared minus 3x minus 7. So we can easily fill that in ourselves. And for the straight line, y equals to 5 minus 2x. So let's start off with the simpler one first, the straight line. It is sloping down. You have to recognize that this is of the form y equals to mx plus c, because I can easily rearrange this to become y equals to negative 2x plus 5. So let's verify that everything is correct. Gradient, negative 2, sloping down. Okay, good. Y-intercept, positive 5. As shown over here. Everything is okay. Next, for the curve. Coefficient of x squared is positive 2. We are expecting a smiley face. One more thing that we can do very quickly is, if I substitute x equals to 0, watch what happens when I substitute x equals to 0 for both the straight line and the equation. For the straight line, 5, y equals to 5 minus 2 times 0, so we get 5. That is the y-intercept. If we do the same thing, where x equals to 0 for the quadratic, we end up with y equals to negative 7, which is our y-intercept for the curve. Okay, so depending on the, actually it doesn't depend. As long as you sub x equals to 0, you will end up with vertical intercept. That is if your horizontal axis is your x, vertical axis is your y. Okay, so next, solve 2x squared minus 3x equals to 12 minus 2x graphically. Okay, so it says graphically. If you use your manipulation, that means you want to make it into the form, group all the x squared term, group all the x term. You want to make it like this, and you end up trying to factorize. Suppose you manage to do so. Sorry, x equals to something, or x equals to something. Suppose you manage to do so. You will not get any marks because they said do it graphically. So for those of you who actually try doing this, you realize that you did not manage to factorize, because the numbers that we expect over here, they're not integers. They're not something that we can easily guess and check. So no, that is not the method. Instead, they said solve it graphically. So graphically means we need to refer back to our graph. Again, whenever they ask you to solve equations graphically, manipulate it back to whatever you have before. On your graph, what do you already have? You already have 2x squared minus 3x minus 7 for y. You already have 5 minus 2x for y again. Look back closely at what they ask you to solve. 2x squared minus 3x. Does it look familiar? Does it look familiar? If it doesn't, you can expect to manipulate it into the graphs that are already drawn. Or more typically, the graphs that you would have drawn. So let's start from here. First step, 2x squared minus 3x equals to 12 minus 2x. Copy, new equation. That's our first step. Once you have copied down the new equation, change it into the form that you already have. I want 2x squared minus 3x minus 7. So on the left-hand side, you just focus, pay very close attention and try and follow me. For the second line, see that this portion is the same. These are the same so far, right? First step, second step, same. what did they do in the second step? They included a -7. Why did they want to do that? Because we already have the graph y equals to 2x squared minus 3x. 2x squared minus 3x minus 7. We already have that, and I want to create that in my new equation. So I do so. Simply put a -7. And now we recognize that, hey, now the left-hand side is my existing quadratic graph. That is what I want. I cannot just put a -7 on the left-hand side without doing anything on the right-hand side, because they will no longer be equal. So I have to do so on the right-hand side as well. With that, let us look at what we have on the right-hand side this time. Because whatever we have on the right-hand side must be the graph that I need to draw. Let me put on the step 2. Step 2, manipulate manipulate equation to obtain right-hand side of existing existing quadratic graph. Manipulate the equation to obtain the right-hand side of the existing quadratic graph. So this refers to our 2x squared minus 3x minus 7. I need to see this. So within this step 2, it also requires you to, whatever you do on the left-hand side, you must do on the right-hand side. In step 3, after you obtain right-hand side of quadratic graph, draw y equals to the right-hand side of new equation. Where is my new equation? This is my new equation. Right-hand side of the new equation says y equals to 5 minus 2x. So in my working, I'll need to go over here, draw y equals to 5 minus 2x. Draw the arrow over here. Draw y equals to 5 minus 2x. This is our step 3, which is a straight line, which is not difficult. Draw a table of values. You need 3 sets of coordinates. But is it already drawn for us? In this case, y equals to 5 minus 2x. Yeah, we already have that. It is already drawn for us. Wow, this teacher will make your life very simple. Everything drawn for you. We just want to see your manipulation. So now that we have the 2 graphs, final step, step number 4, solution. Might be 1, might be 2 solutions. Solutions will be our x coordinates of points of intersection. So look for the 2x coordinates where the 2 graphs meet. They will be x equals to -2.2 or 2.7. Almost guaranteed that this will be tested. Make sure you know how to do it. Requires you to keep revising this. Knowing how to do it now doesn't mean that you will remember how to do it again. So before the exam, go and revise this one again. So next one, using the graph, solve. 2x squared minus 3x minus 7 equals to 5. Okay, let's make use of our steps over here. The steps that we created. So B part 1, 2x squared minus 3x minus 7 equals to 5. Okay, now follow my own notes. Step 1, copy new equation. 2x squared minus 3x minus 7 equals to 5. Let's go to step 2. It says manipulate the equation to obtain the right hand side of the existing quadratic graph. What is the existing quadratic graph? Y equals to 2x squared minus 3x minus 7. This is the right hand side of existing quadratic graph. So I need to manipulate my new equation to obtain 2x squared minus 3x minus 7. 2x squared minus 3x minus 7. Oh, it's already done. It is already of the form. I'm happy lah. Okay, so my step 2 is actually exactly the same as step 1, which means that you didn't need to write this in the first place. There's no need to manipulate. This is a simple basic question. Let's go to step 3. After you obtain the right hand side, okay, meaning this portion, the right hand side of the existing quadratic graph, draw y equals to the right hand side of the new equation. This is my new equation. Draw y equals to the right hand side. The right hand side says 5. Draw y equals to 5. Not difficult. It is a horizontal line. Let's draw y equals to 5. So we're looking at level 5. This is my graph of y equals to 5. After I've done that, step 4 says the solutions are the x coordinates or the points of intersection. Okay, the blue line that I've drawn now intersects the straight line, the diagonal line of y equals to 5 minus 2x. It also intersects my quadratic curve. So it looks like I've got one point of intersection, another point of intersection, another point of intersection. Do I accept all three? Are all 3 points of intersections relevant? For B part 1, solving this equals to 5. It's got nothing to do with your diagonal line. Nothing to do with the diagonal line. It is just between the curve and the horizontal line you've drawn. It's got nothing to do with the diagonal line. So make sure you know which equations you are interested in. Now in this case, look out for its x values. This over here we have negative 1.8. That is my first x coordinate. The second x coordinate, according to the graph, it looks like 3.3. So typically what I do is I'll put on my label over here as well. B part 1. Over here, B part 1. There's too many numbers all over the place, maybe hard to see. Okay, so x equals to negative 1.8 and 3.3. See, by drawing x equals to 5, x equals to negative 1.8 or 3.3. Okay, now B part 2, good stars. It is a variation of whatever we have done earlier on. It is a variation of, by drawing another graph, find the solutions graphically for the new equation, blah, blah, blah. This is a different variation. And recently, this is popular. Recently only. Explain why 2x squared minus 3x minus 7 equals to k does not have solution for some values of k. You understand what is it talking about? Who was able to understand this? Not many. Who don't know what this is talking about? This B part 2. Yeah. That's why it only recently became more popular. Okay. Let's try and break it down. Explain why the equation 2x squared minus 3x minus 7 equals to k. Let's focus on this portion first. The strange thing is that why does it say it is equal to k? I mean, algebra itself is sometimes challenging enough, right? Now, instead of saying a number equals to don't know, previous case. Oh, was it? Equals to 5. Hey, look at B part 1. Maybe we can get a clue from here. 2x squared minus 3x minus 7 equals to 5. B part 2. 2x squared minus 3x minus 7 equals to k. Can you see that they are kind of similar? B part 1 and B part 2. The left-hand side is just 2x squared minus 3x minus 7, which is part of the quadratic graph that we have drawn. And now it says it is equal to k. Earlier on, it says it is equal to 5. We could understand B part 1. We only had to draw a horizontal line, y equals to 5, and we look for points of intersection to get a solution. Now in B part 2, it says this time it is equal to k. What if I change this question, just to help you understand, equals to 2. What will you do to find the solution? Okay, find solution of this. 2x squared minus 3x minus 7 equals to 2. What will you do? Harry, what will you do? Draw y equals to 2. And find points of intersection, right? Let's see what it looks like. So according to that, we draw y equals to 2, which is over here. Draw y equals to 2, find points of intersection. So this is our answer. X equals to whatever. I've got another answer, x equals to 3. Y equals to 2. Change question again. Follow on. It's going to be a bit repetitive, but I need to ensure you understand what is happening. Find the solution of 2x squared minus 3x minus 7 equals to 11. What will we do? Ning Kuan. Draw y equals to 11. Okay, correct. Draw y equals to 11. So y equals to 11 is over here. Again, there will be 2 x values for the x coordinates where they intersect. 2 values again. What happens? We say 2x squared minus 3x minus 7 equals to 0. Omera, what do you think happens over here? What should we do? What about y equals to 0? Draw y equals to 0, which happens to be our horizontal axis. Draw y equals to 0. Again, I see 2 solutions. Next one, I want to see it equal to negative 5.5. Okay, what should we do? Draw. What do you say we think? Draw negative 5.5. 5.5, negative 5.5 is a number. I cannot draw a number. Draw the line. What do you say? Louder, louder. Draw a line of negative 5.5. What does that mean? I think you're missing a very special, a very important letter. Y equals to, right? You cannot draw a line negative 5.5. You mean a vertical line, horizontal line? Okay, so it depends. You have to say, okay, now draw net y equals to negative 5.5. Negative 5.5 is here. Y equals to negative 5.5. Okay, Akira, how many points of intersection? Y equals to negative 5.5, the one that Hao just mentioned. And the curve, how many points of intersection? How many times does this line intersect the curve? Oh yeah, sorry. Yeah, that's not 5.5. That is yeah, I was trying to get this line. I thought this was negative 5.5. Okay, never mind. So we leave that question to later on. Negative 5.5 is here, right? Okay, this one. Okay, so now Akira, you get an easier question. So Akira, how many times does it intersect? This line? How many times does it intersect? Intersect means cut. How many times does this line cut the curve? Have some confidence in yourself. 2, 1, 2, 2 solution. Okay, the line that I really wanted Hao Tian to say, right, was this line, so I gave it away already. Okay, so this line has equation y equals to 5, 6, 7, 8, -8. This is the line y equals to -8. Okay, Zheng Jie, how many times does this line intersect the curve? 1 time, yes, 1 time. You saw that earlier on, whatever examples I gave, right, intersect 2 times. But this is a very special line, y equals to -8. It corresponds to the equation over here equals to -8, right? So if I show this equation, then Zheng Jie will say draw y equals to -8. Then we draw y equals to -8. Only got 1 point intersection, only 1 solution. What is the solution? The solution is whatever this value is. Okay? Understand so far? Very repetitive, right? What I was trying to do is to show you that different values of k causes us to draw different graphs. What were all the different graphs? They were all y equals to a certain number. The number is k. Whatever that number is, results in a different horizontal line being drawn. Different horizontal line. So when the horizontal line is above y equals to -8, we had 2 solutions. When the graph just nice y equals to -8, there was only 1 solution. Because only 1 point intersection, right? Okay, now let's move down to see exactly what they wanted. When does it have does not have solution? When does it not have any solution? Above -8, 2 solution. At -8, 1 solution. Where do we draw the line? This horizontal line, such that it does not intersect the curve. Is it possible to draw a horizontal line so that it don't touch the curve? Possible. 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 Where is it? Where? Draw anything above -8 is 2 solution, right? At -8 is 1 solution, right? Where else can we draw? Yeah, where else can we draw the horizontal line such that there is no solution? Huh? What? Where? Below. Below -8. When you draw a horizontal line below y equals to -8, you see that it doesn't touch the curve, right? Because this is called a minimum point for a reason. It is the minimum already. You draw anything below that, no intersection. So whenever we draw a graph lower than y equals to -8, when this happens, no solution. So the particular value of k that I am interested in is -8. When k is less than -8, okay, there's a negative sign over there. When k is less than -8, so we are talking about -8.1, -8.2, -8.000000001. As long as it's less than -8, there is no point of intersection, which implies no solution. So very important concept over here. Okay, I will pause the sharing over here first. I want all of you to take out your